Hi friends, welcome back. This is Santosh Kumar. So today we'll continue with the phase margin. Last time we discussed what is the gain margin, what is the gain crossover frequency, isn't it? So today I'll elaborate this. It will be clearly understood by you people. Okay. So let's come to the last gain margin first. The gain margin we have given by this formula mathematically, that is reciprocal of the magnitude of the plot or of the system at omega PCF. This one is very important. Omega PCF is nothing but the the phase or minus 180 degree phase. Whenever your phase plot or the plot of the given system is cutting to the minus 180 degree, at that point only we are considering the gain margin. So at that point, that frequency we call the PCF, isn't it? So that's why omega should be omega PCF. So gain margin is clear to you, I think, isn't it? So this is the margin by which we can increase the system, or the system will increase by this margin, so it will become unstable. Okay, this diagram is very important. Okay, today we'll discuss about this diagram more and more, so it will be clear to you. Now let's come to the phase margin. So come over here. Again the diagram is same. Earlier we discussed about this. The phase margin is defined as the amount of additional phase leg at omega GCF. Now what is the omega GCF? If you remember, the gain margin we were calculated for the omega PCF. The relation of gain margin is with omega PCF, we have seen, and the relation of the PM will be omega GCF, definitely. How? See, omega GCF is nothing but the frequency at which omega, this is GCF, the frequency at which the gain of the system is 1, isn't it? So over here we are getting some phase. We have some phase of the system. Okay, so this is the additional phase. If you will give this phase to the system, your system will come over here, isn't it? So this is your system. If this additional phase, if you will give to the system, the next plot will be like this, isn't it? So friends, this plot is just a verge of instability. Once your plot will come like this, this is the unstable system. Okay, we'll discuss more in the next unit, but for the time being you have to remember this. Okay, in the next page only I'll discuss about the diagram only. Just come to the phase margin definition that says the define as the amount of additional phase leg. This is the practically or physically the amount of this additional phase leg. If you'll provide to the system, it will come to the verge of instability. Okay friends, so how you will give this? PM is given by this formula, 180 degree plus angle of Gj omega, the angle provided by system, and the frequency is taken over here, omega Gc. This is the formula for PM, isn't it? And the formula for GM we have seen. This is the reciprocal of magnitude at omega equal to omega PCF. Suppose if you will convert this into dB, so dB, if you will convert, you will take 20 log 1 by GH j omega, isn't it? So when this denominator term will go up, so the minus sign will come out and you will remain with GH j omega, isn't it? So this is in dB. The gain margin is in dB is minus 20 log this, or you can take this one only, 20 log 1 by magnitude. Okay, so the gain margin is given by this formula, the phase margin is given by this formula, 180 degree plus angle of system at omega GC. Omega GC is nothing but, let's come to the next one so it will be okay to you. So this is the diagram. Please try to remember this. In the next unit we are going to discuss this type of diagrams only. That is the polar plot. Okay, so over here in the Bode plot, this one is very important. Try to understand this. This plot is for the stable system. This plot is for the stable system, and this is for marginally stable system. This is for unstable system. Okay, so what this system says, see, for this system, this is nothing but omega, tell me, PCF, isn't it? And this frequency, the frequency where the plot is gaining the 1 or the magnitude is 1, is nothing but omega GCF, isn't it? So what I am saying, and this plot is always starting from omega equal to infinity to omega equal to 0. Okay, don't be panic. In the next unit we'll discuss about this only, but here you have to remember this. This is the ready-made thing I'm going to provide you. So let's come to the point. The point is, if this is the stable system and we are coming from the infinity, so this is like 10 to the power 6, 10 to the power 5, 10 to the power 3 and something like this over here. So the frequency is going to decrease, isn't it? Because we are reaching to 0, from infinity to 0. So who will be greater than between these two, omega PCF and omega GCF? Who will be greater than for the stable system? Definitely omega PCF, because this is the infinity. Here, if this is 10 to the power 3, it will be going to reduce 10 to the power 1 and finally it's a 0. Omega PCF is always greater than omega GCF. This is the 100% stable system. Stable system, and that is 100%, isn't it? Very important. Sometimes directly you can get it in the examination. Okay, now let's come over here. Where is the omega PCF? Omega PCF is the frequency over which the magnitude or the plot of the system is intersecting minus 180 degrees. So this is omega this is PCF. Where is the omega GCF? And remember, this is the unit circle, okay? Unit circle. So the magnitude 1 is coming over here. So omega PCF and omega GCF both are over here only, GCF. So omega PCF is equal to omega GCF, and this is the condition for marginally stable system, isn't it? Now if I am saying this is the unstable system, so let's find out the frequency for this. This is the frequency, that is omega PCF, and this is the frequency omega GCF. So in this case, omega GCF is greater than omega PCF, and this is the condition for instability. This is the condition for instability. If gain crossover frequency is greater than phase crossover frequency, your system will be 100% unstable system. If both are equal, the system will be, tell me, marginally stable. If omega phase crossover frequency is greater than omega GCF, your system will be stable system. Now let's talk about gain margin and phase margin. What will be the gain margin? What will be the phase margin? The relation I'm talking about for the stability. Okay. So for the stable system, let's come for the stable system, isn't it? Stable system, this is the plot for the stable system. The magnitude over here is less than 1, isn't it? Because 1 we are getting here, it's a 0.5 or 0.4 or 0.6, whatever. The gain margin will be always greater than 1 or not, tell me. The gain margin, because the gain margin is the reciprocal of the magnitude. So gain margin will be always greater than 1, isn't it? Okay friends, so gain margin is greater than 1 in the linear, and in the dB it is always greater than 0. If you'll find out in dB, the gain margin, it will be always greater than 0 dB. Means it's positive we are getting. What about the phase margin? Phase margin for this system is this, the remaining portion is nothing but the phase margin, isn't it? So this is always positive, because 180 degree minus this you will get, so this will be 30 or 50 or 60, so this one is also positive. isn't it? The phase margin for this system is positive. The gain margin for this system is positive. System is a stable system, isn't it? And what about the next one? Means marginally stable system. Marginally system, the gain margin will be 1, isn't it? The gain margin is 1. What about the PM? The PM will be 0. The formula of PM is 180 plus angle of GH at omega GCF. So at exactly this one, we are calculating the angle clockwise. That will be minus 180 degree. It will be minus 180 degree and will become 0, isn't it? When you will calculate at omega GCF, definitely you will get the negative. You can try it. Always you will get the negative over here. So it will become 0. And because of this only I am saying if you will get 150 over here, so you will get plus 30. Plus 30 belongs to stable system category. So this is for the marginally stability, the relation or the condition for the GM and PM. And for the unstable system, your magnitude is greater than 1 and GM is reciprocal of magnitude. So GM will be less than 1, isn't it? If you will find out in dB, 20 log 0.5 if you will find out, you will get in minus. So in minus dB. Now this is the phase. This is the phase. See, you have given extra. So minus 180 from this axis you are calculating. Wait a minute. From this axis your angle is greater than 180 degree. So this is 180 degree minus 225 suppose. So we'll get minus 45 degree minus. It will be in minus. Your phase margin is also in minus. Phase margin is negative. So if phase margin and gain margin both are negative, your system will be unstable system. Okay friends, so this is all about today's class. In the next class we'll further discuss about this and we'll take the problems. Okay, so we'll meet in the next class. Till then, take care and bye.